Hi, welcome to Algebra 2 Common Core. In this lesson, we're going to revisit inverse functions, this time specifically talking about inverses of linear functions. So let's review what an inverse is. Remember that we can find an inverse if a function is one-to-one. So we are going to take a look first of all at graphs. First of all, we have to have a one-to-one function in order for the inverse to also be a function. So we're going to start with one-to-one. We know that in order to have a one-to-one function, it has to pass the horizontal line test to begin with. So today, looking at inverses of linear functions, the only linear function that's not going to be one-to-one is going to be a line that's a horizontal line. All the rest of the linear functions will have an inverse because they do pass the horizontal line test. So when we are looking at graphs, remember that what we want to do is take any coordinate x, y, and reflect it over the line y equals x, which means that now we have the ordered pair y comma x. So basically we switch the y and the x coordinate to find the inverse coordinate. Let's start with exercise number 1. In exercise number 1, we have the equation y equals 2x minus 4. You'll notice that the graph of this function is right here. Now we've also graphed the line y equals x so that we can see that y equals 2x minus 4 will be reflected over that line y equals x. But before we get to finding the inverse, let's identify the fact that y equals 2x minus 4 is a one-to-one function. So we're going to say yes, it is one-to-one. We know that it is one-to-one because it passes the horizontal line test. So now in order to graph the inverse function, I'm going to make a table of values for my original function, the function that's given to me, y equals 2x minus 4. I'm specifically looking at points that are designated on the graph. So the first point that I'm looking at is going to be the point -1, -6. I see that we also have the point 0, -4. We have the point 1, -2. Proceeding, we still have another point here that's going to be the point 2, 0. There's a couple more that we can look at, 3, 2. And lastly, let's go to 4, 4. There is another one up at the top as well. We could put that on our graph too. Now when I'm trying to find the inverse, I'm going to make a new table of values, but this time all I'm going to do is reverse the x and the y coordinates. So this is going to be the table of values for my inverse function. So instead of -1, -6, we're going to have -6, -1, -4, 0, -2, 1, 0, 2, 2, 3, and also 4, 4. Pause the video, plot those points, and come back and see if your inverse graph matches with mine. Welcome back. Take a look at your graph and see if it matches the one that I have drawn. You'll notice that each point is reflected over the line y equals x. So if we folded our paper along that diagonal line, the original function should be reflected onto the blue graph, the graph of the inverse. How are these two functions related to each other? They are inverses, but inverses are just going to be a reflection over the line y equals x. Lastly, we want to find the equation of that inverse in slope-intercept form. So we can take a look at the graph and see that the slope of the inverse graph is going to be 1/2. For every point, I go up 1 and over 2 to get to another point. I can also look to find the y-intercept on the y-axis. That's equal to 2. So my equation in slope-intercept form is going to be y is equal to 1/2 x plus 2. That leads us to the steps that we used in the last chapter to find an inverse of a 1-to-1 function. We can also find an inverse algebraically as well as graphically. So to find this inverse algebraically, remember that what we do with our equation is switch the variables x and y, and then we will always want to solve for the y. Once we solve for the y, if our function was given to us in terms of f of x, then the notation that we can use is f to the negative 1 of x to stand for the inverse. Now again, in this unit, we are just focusing on inverses of linear functions. So let's go ahead and use that technique to solve the next 3 exercises. So for the equation y equals 5x minus 20, I'm going to reverse the x and the y. So I have x is equal to 5y minus 20. To get the y by itself, we'll add 20 to both sides of the equation, and then we'll divide both sides by 5, or take 1/5 of both sides. So this is giving me 1/5 x plus 4 is equal to my y. Go ahead and find that on your paper. That's this multiple choice answer. Let's do the same thing with exercise number 3. Y equals 2/3 x plus 8. I'm going to switch over to red and put it up here. X is equal to 2/3 y plus 8. Now sometimes algebraically it gets a little tricky to get the y by itself, so be careful and show all of your work. Please put this work in your notes. So I have now subtracted 8 from both sides. But then to get the y by itself, we're going to have to multiply both sides by 3/2. So I'm going to say 3/2 multiplied by x minus 8. Now I can distribute that 3/2, so I'm getting 3/2 x. 3/2 times a negative 8 is giving me negative 12. So my answer this time should be y equals 3/2 x minus 12. Choice number 2. In exercise number 4, we want to find the y-intercept of the inverse. So let's first of all go ahead and solve for the inverse. So let's go ahead and switch the x and the y. So we have x is equal to 3/5 y minus 9. Adding 9 to both sides of the equation, I have x plus 9 is equal to 3/5 y. And then I'm going to multiply both sides of the equation times the reciprocal, 5/3. When I do that on the right side, I'm going to cancel off the fractions. So I get y is equal to, let's distribute that 5/3, so that gives me 5/3 x plus 15. So my equation of the inverse is going to be y is equal to 5/3 x plus 15. Now this question asks us, let's label that as the inverse. This question is asking us to identify the y-intercept of that inverse. So of course, to find the y-intercept, in y equals mx plus b form, the b value for this problem is equal to 15. So that's my y-intercept. Remember that the y-intercept is also the y-answer when x is equal to 0. So we could have substituted a 0 in for x. So 5/3 times 0 plus 15 also gives us that final answer for our y-intercept of 15. Please pause the video and try exercise number 5 on your own. Come back and check your work with my work. Make sure you're showing your work in your note packet, as well as giving the correct answer. Check your work with my work shown above. You'll notice that for this one, we didn't have to distribute the 1/4 through the parentheses. So in the form that it was given, this is actually the point slope form of the line, because it shows that the slope is equal to 1/4. Let's go ahead to exercise number 6. This one says, which of the following points lies on the graph of the inverse of the given function? And explain your choice. So I'm going to go ahead and find the inverse equation first of all. We may not have to simplify it all the way through. So I'm going to write this as x minus 8 is equal to 5 times y plus 2. So I want to find a point that's going to satisfy this equation. So starting with choice number 1, when I substitute 8, negative 2 into my equation, I get 8 minus 8 is equal to 5 times negative 2 plus 2. And lucky for us, this happens to work because I get 0 on the left side equals 5 times 0 on the right side. So this point does work, and the point 8, negative 2 is a point that is on the inverse. So I've written the equation of the inverse here. If I try any of the other points, for example, let's try negative 8, 2. Negative 8 minus 8 is equal to 5 times 2 plus 2. That doesn't work because I get negative 16 is equal to 5 times 4, which is 20, and that, of course, is not congruent. Trying any of the others, I see that they do not work as well. So the only one that does work in this situation is number 1. Let's take a look at the last exercise. This time we're given that the inverse function is negative 3/4 x plus 2, and we want to go the other direction and find the function f of x. Now, if you take a look at the graph of any function and its inverse, you know that it's just a reflection over the line y equals x. So it doesn't matter whether I start with the original function or with the inverse. In either case, they actually are inverses of each other. So if I know the inverse, I can find the function by following exactly the same process. So I'm going to start with the inverse and call it y is equal to negative 3/4 x plus 2. I'm going to mark that inverse. So theoretically, all I'm doing is taking the inverse of the inverse to get back to the original function. So to find the function, we'll go back and we'll switch the x and the y just like we did before. So x is equal to negative 3/4 y plus 2. Solve for y, so we're going to subtract 2 from both sides. And then multiply by the reciprocal fraction. So negative 4/3 times x minus 2 is equal to y. I'm going to have to go ahead and distribute that negative 4/3, so I get y is equal to negative 4/3 x, and then multiply negative 4/3 times negative 2, and that gives us positive 8/3. So the choice that we are going to pick is choice number 2. We could also take that answer and go through the process again by switching the x and the y and solving for y, and make sure that we get back to the original function that we were given, which happened to be the inverse function. We'll be working some more with inverse functions in class. Have a good night.